Good day everyone. So today I will be discussing how I got my answer in our output 6 in abstract algebra. So number 1, prove that the set of even integers is a subgroup of the additive group of the integers. So dito, nakalagay na set of even integers and group of the integers. So, dito kailangan nating i-prove na kung yung set of even integers ba is a subgroup of the additive group of the integers. So, meaning, hahanapin natin yung apat na properties, which is yung closure, associative, identity, and inverse. Para ma-prove natin kung ito nga ba is a subgroup. So, sabihin natin yung CE is our set of even integers. And yung C, set of integers. Since nakalagay dito sa given na additive, so meaning addition yung gagamitin natin. So, umpisahan muna natin sa closured. So, dito sa closured, mag-iisip lang tayo ng dalawang number na even integers, and then kapag inad siya, dapat yung makuhang sagot is also a even integers. So, sabihin natin 2 and 4. So, 2 plus 4 is equal to 6. So, yung 6 is even integers then. Then, 4 and 6. So, 4 plus 6 is equal to 10. So, yung 10 is also a even integers. So, dito magiging 2 times n sub 1 plus n sub 2. So, kapag nire-write natin to, magiging 2 times n. So, etong n natin, so eto siya. And then, etong 2 na nasa labas, siya yung even integers natin. So, proceed tayo sa associative. So, dito sa associative, meron tayong ginagamit na formula which is yung a plus b plus c is equal to a plus b plus c. So, ito yung gagamitin natin. Yung 2, isa-substitute natin sa a, yung 4 sa b, and then yung 6 sa c. So, ayun, substitute lang natin. So, yung a is 2 plus b yung 4 plus 6 since sa yung c natin. Then, etong a, 2 plus 4 plus 6. So, add lang natin to. So, 2 plus 4 is equal to 6. Then, etong 6, baba lang natin. Then, etong 2, baba lang. Then, 4 plus 6 is equal to 10. So, 6 plus 6 is 12. Then, 2 plus 10 is 12. So, same siya ng answer, meaning, ito ay associative. So, dito, napatunayan natin na etong additive is associative. So, proceed tayo sa identity. So, dito sa identity, yung formula naman na ginagamit natin is A plus E is equal to A. So, kapag addition, dapat 0 yung makuha nating identity. So, yung A natin magiging 2n. So, substitute lang natin siya. 2n plus E is equal to 2n. So, kailangan ilang yung matira. So, ang gagawin natin dito sa 2n, itatranspose lang natin siya dito sa kabila. So, magiging 2n minus 2n kasi magiging negative siya. So, 2n minus 2n makakancel. So, meaning 0 na siya. So, yung identity natin is equal to 0. Next, proceed na tayo sa inverse. So, dito sa inverse, ang ginagamit naman nating formula is a plus a raised to negative 1 is equal to e. So, dito, hahanapin naman natin yung inverse. So, etong a raised to negative 1 yung inverse natin. So, substitute lang ulit natin yung 2n sa a plus eto, baba lang tong a raised to negative 1 is equal to e. So, yung e natin is 0 o yung identity natin. So, ganun ulit yung gagawin. I-transpose lang to sa kabila. So, magiging a raised to negative 1 is equal to 0 minus 2n. So, kapag minus to, magiging a raised to negative 1 is equal to negative 2n. So, rewrite lang natin siya para maging a raised to negative 1 is equal to 2 times negative n. So, dito, napatunayan natin na siya ay closure, associative, identity, and inverse. So, therefore, the set of even integers is a subgroup. So, number 2, find the order of each element in the additive group of C11. So, ang element ng C11 is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then, since additive, so addition, and then modulo by 11, kasi Z11. So, ang unang gagawin dito is hahanapin natin yung subgroup ng element ng Z11. So, sulat muna natin yung 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Since para mahanap yung subgroup, gagamit tayo ng colon. So, lagay muna ako ng colon. So, para mahanap yung subgroup, gagamit lang ng continuous addition. So, 0 raised to 1 is equal to 0. So, dito kapag nahanap natin yung identity, pwede na tayo mag-stop. Since addition, so yung identity ng addition is equal to 0. So, kapag nahanap yung 0, pwede na tayo mag-stop. So, proceed na tayo sa element ng 1 since nahanap na natin sa element yung 0. So, 1 raised to 1 is equal to 1. 1 raised to 2 is equal to 2. 1 raised to 3 is equal to 3. 1 raised to 4 is equal to 4. 1 raised to 5 is equal to 5. 1 raised to 6 is equal to 6. 1 raised to 7 is 7. 1 raised to 8 is 8. 1 raised to 9 is 9. Then 1 raised to 10 is 10. Then 1 raised to 11 is equal to 11. Then 11 modulo by 11 is equal to 0. So, nahanap na natin yung identity. So, pwede na tayo mag-stop. Proceed na tayo sa element ng 2. So, 2 raised to 1 is equal to 2. 2 raised to 2 is equal to 4. 2 raised to 3 is 6. 2 raised to 4 is equal to 8. 2 raised to 5 is equal to 10. 2 raised to 6 is 12, modulo by 11, so 1. 2 raised to 7 is 14, modulo by 11, so 3. 2 raised to 8 is equal to 16, modulo 11, so 5. 2 raised to 9 is equal to 18, modulo 11, so 7. Then 2 raised to 10 is equal to 20, 20 modulo 11, so 9. Then 2 raised to 11 is equal to 22. So 22 modulo 11 is 0. So pwede na tayo mag-stop since nahanap na yung identity. So proceed na tayo sa element ng 3. So 3 raised to 1 is 3. 3 raised to 2 is 6. 3 raised to 3 is 9. 3 raised to 4 is 12. Modulo 11. So 1. 3 raised to 5 is 15. Modulo 11. So 4. 3 raised to 6 is 18. Modulo 11. So 7. 3 raised to 7 is equal to 21. Modulo 11. So 10. 3 raised to 8 is equal to 24. Modulo 11. So 2. 3 raised to 9 is equal to 27. Modulo by 11. So 5. 3 raised to 10 is equal to 30. So modulo 11. So 8. Then 3 raised to 11 is equal to 33. So 33 modulo 11 is equal to 0. So nahanap na natin yung identity. So it means pwede na tayo mag-stop. So proceed naman tayo sa identity ng 4 or sa element ng 4. So sa 4, 4 raised to 1 is equal to 4. 4 raised to 2 is equal to 8. 4 raised to 3 is equal to 12. So modulo 11. So modulo 11 is equal to 1. Then 4 raised to 4 is equal to 16. Modulo 11, so 5. 4 raised to 5 is equal to 20. Modulo 11, so 9. 4 raised to 6 is 24, modulo 11, so 2. 4 raised to 7 is 28, modulo 11, so 6. 4 raised to 8 is 32, modulo 11, so 10. 4 raised to 9 is 36, mod by 11, so 3. 4 raised to 10 is 40, and modulo by 11, so we have 7. Then 4 raised to 11 is equal to 44. Then 44 modulo 11 is 0. So, nahanap na natin yung identity. So, stop na. So, sa element naman ng 5. So, 5 raised to 1 is equal to 5. 5 raised to 2 is 10. 5 raised to 3 is 15 modulo by 11. So, 4. 5 raised to 4 is equal to 20 modulo by 11. So, 9. 5 raised to 5 is equal to 25, modulo 11, so 3. 5 raised to 6 is 30, and modulo 11, so 8. 5 raised to 7 is equal to 35, modulo by 11, so 2. 5 raised to 8 is equal to 40, and modulo by 11, so 7. 5 raised to 9 is equal to 45, modulo 11, so 1. Then 5 raised to 10 is equal to 50, and modulo by 11, so 6. Then 5 raised to 11 is equal to 55. So 55 modulo by 11, so 0. So it means, nahanap natin yung identity. So proceed na tayo sa element ng 6. So 6 raised to 1 is equal to 6. 6 raised to 2 is 12, modulo 11, so 1. 6 raised to 3 is 18, modulo by 11, so 7. 6 raised to 4 is 24, modulo 11, so 2. 6 raised to 5 is 30, modulo 11, so 8. 6 raised to 6 is 36, modulo 11, so 3. 6 raised to 7 is 42, modulo by 11, so 9. 6 raised to 8 is equal to 48, modulo by 11, so 4. Then, 6 raised to 9 is 54, modulo by 11, so 10. Then, 6 raised to 10 is 60, modulo 11, so 5. 6 raised to 11 is 66, so 66 modulo by 11 is equal to 0. So, nahanap na natin. So, stop na tayo. So, ganito lang yung gagawin. Hahanapin lang yung subgroup ng element and gagamitin lang yung continuous addition. So, sa 7, meron tayong 7, 3, 10, 6, 2, 9, 5, 1, 8, 4, and 0. Next, sa element naman ng 8, we have 8, 5, 2, 10, 7, 4, 1, 9, 6, 3, and 0. Sa element naman ng 9, we have 9, 7, 5, 3, 1, 10, 8, 6, 4, 2, and 0. And then sa element naman ng 10, we have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. So, ayan, nahanap na natin lahat ng subgroup ng element of C11. So, ang next naman na gagawin is i-generate lang natin to sa order of each element. So, we have order of 0 generates into 0. Order of 1 generates to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 0. Order element of 2 generates to 2, 4, 6, 8, 10, 1, 3, 5, 7, 9, and 0. Order of 3 generates 2, 3, 6, 9, 1, 4, 7, 10, 2, 5, 8, and 0. Order elements of 4 generates into 4, 8, 1, 5, 9, 2, 6, 10, 3, 7, and 0. Order 5 generates into 5, 10, 4, 9, 3, 8, 2, 7, 1, 6, and 0. Order of 6 generates into 6, 1, 7, 2, 8, 3, 9, 4, 10, 5, and 0. Order 7 generates into 7, 3, 10, 6, 2, 9, 5, 1, 8, 4, and 0. Order 8 generates to 8, 5, 2, 10, 2, 10, 7, 4, 1, 9, 6, 3, and 0. Order 9 generates to 9, 7, 5, 3, 1, 0, 10. So, walang 0, sorry. So, we have 9, 7, 5, 3, 1, 10, 8, 6, 4, 2, and 0. And last, order 10 generates to 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. So, ayun, na-generates na natin yung subgroup. Ang next naman na gagawin is hahanapin yung order of each element since naka-indicate siya sa given natin. So, order elements of 0 is equal to 1 since meron lang siyang isa. Order elements of 1 is equal to 11 since meron siyang 11. Then order elements of 2 is equal to 11. Order elements of 3 is 11. Order elements of 4 is equal to 11. Order 5 is equal to 11 kasi 11 din siya. Order 6 is equal to 11. Order 7 is equal to 11. Order 8 is 11. Order 9 is 11. Then, order 10 is also 11. So, lahat siya simula sa order of element 1 since 10 is puro na siya 11. So, nahanap na natin lahat. So, proceed na tayo sa number 3. Show that the additive group of Z9 is cyclic. What are the possible generators of this group? So, dito, kailangan natin tingnan kung yung Z9 ba is acyclic. Then, para malaman kung cyclic ito o hindi, hahanapin natin yung subgroup ng elements ng C9. So, yung element ng C9 is 0, 1, 2, 3, 4, 5, 6, 7, and 8. Then, additive, so addition or plus. Then, 9, dahil modulo 9, since Z9 to. So, hanapin na natin yung subgroup ng element 0, 1, 2, 3, 4, 5, 6, 7, and 8. So, para mahanap yung subgroup, magko-colon tayo. So, colon. Then, gagamit ulit tayo ng continuous addition. So, sa 0, 0 raised to 1 is equal to 0. So, ayan, nahanap na natin yung identity. So, it means pwede na tayo mag-stop. Then, so 1 raised to 1 is 1. 1 raised to 2 is 2. 1 raised to 3 is 3. 1 raised to 4 is 4. 1 raised to 5 is 5. 1 raised to 6 is 6. 1 raised to 7 is equal to 7. 1 raised to 8 is equal to 8. Then 1 raised to 9 is equal to 9. Since kailangan natin siyang i-modulo 9, so 9 modulo 9 is equal to 0. So nahanap na natin yung identity. So stop na tayo. Proceed na tayo sa element ng 2. So 2 raised to 1 is 2. 2 raised to 2 is 4. 2 raised to 3 is 6. 2 raised to 4 is 8. 2 raised to 5 is 10. Modulo 9, so 1. 2 raised to 6 is 12. Modulo 9, so 3. 2 raised to 7 is 14. Modulo by 9, so we have 5. 2 raised to 8 is 16. Modulo 9, so 7. 2 raised to 9 is 18. And modulo by 11, so we have 0. So, stop na tayo. Then, proceed na tayo sa element ng 3. So, 3 raised to 1 is 3. 3 raised to 2 is 6. 3 raised to 3 is 9. Modulo by 9, so 0. Next, proceed na tayo sa 4. So, 4 raised to 1 is 4. 4 raised to 2 is 8. 4 raised to 3 is 12. Modulo by 9, so 3. 4 raised to 4 is 16. Modulo by 9, so 7. 4 raised to 5 is 20. Modulo by 9, so 2. 4 raised to 6 is 24. Modulo by 9, so 6. 4 raised to 7 is 28. Modulo 9, so 1. 4 raised to 8 is 32. Modulo 9, so we have 5. And then 4 raised to 9 is 36. So 36 modulo by 9, so 0 na siya. Then, proceed tayo sa element ng 5. So 5 raised to 1 is 5. 5 raised to 2 is 10. Modulo 9, so 1. 5 raised to 3 is 15. Modulo 9, so we have 6. 5 raised to 4 is 20. Modulo 9, so 2. 5 raised to 5 is 25. Modulo by 9, so 7. 5 raised to 6 is 30. Modulo by 9, so 3. 5 raised to 7 is 35. Modulo 9, so 8. 5 raised to 8 is 40. Modulo 9, so we have 4. 5 raised to 9 is 45. Modulo by 9 is 0. So, stop na dahil nahanap na natin yung identity. So, sa element naman tayo ng 6. 6 raised to 1 is 6. 6 raised to 2 is 12. Modulo by 9, so we have 3. 6 modulo by 6 raised to 3 is 18. 18 modulo 9 is equal to 0. So, stop na tayo. Next, sa 7 naman tayo. Sa 7, meron tayong 7 raised to 1 is 7. 7 raised to 2 is 14. Modulo 9, so we have 5. 7 raised to 3 is 21. Modulo by 9, so 3. 7 raised to 4 is 28. Modulo 9, so we have 1. 7 raised to 5 is 35. Modulo by 9, so we have 8. 7 raised to 6 is 42. And modulo 9, so we have 6. 7 modulo by 7, we have 49. Then modulo 9 is 4. Then 7 raised to 8 is 56. Modulo by 9, so we have 2. Then 7 raised to 9 is 63. And modulo 9, we have 0. So, mag-stop na tayo dahil nahanap na natin yung identity. Next, sa element naman ng 9 or 8. So, sa 8, we have 8 raised to 1 is 8. 8 raised to 2 is 16. Modulo 9, so 7. 8 raised to 3 is 24. Modulo by 9, so we have 6. 8 raised to 4 is 32. Modulo 9, so 5. 8 raised to 5 is 40. Modulo 9, so 4. 8 raised to 6 is 48. Modulo 9, so 3. 8 raised to 7 is 56. Modulo 9, so 2. And 8 raised to 8 is equal to 64. Then modulo 9, so 1. Then last, 8 raised to 9 is 72. So 72 modulo 9 is 0. So nahanap na natin lahat ng subgroup ng elements of C9. So ang next naman na gagawin is i-generate lang natin yung subgroup. So order of 0 generates into 0. Order element 1 generates to 1, 2, 3, 4, 5, 6, 7, 8, and 0. Order 2 generates into 2, 4, 6, 8, 1, 3, 5, 7, and 0. Order 3 generates into 3, 6, and 0. Order 4 generates into 4, 8, 3, 7, 2, 6, 1, 5, and 0. Order 5 generates into 5, 1, 6, 2, 7, 3, 8, 4, and 0. And order 6 generates to 6, 3, and 0. Order 7 generates into 7, 5, 3, 1, 8, 6, 4, 2, and 0. And order 8 generates into 8, 7, 6, 5, 4, 3, 2, and 1. 3, 2, 1, and 0. So, ayun, nahanap na natin lahat ng subgroup and na-generate na natin siya. So, kailangan natin siyang i-prove kung cyclic ba ito o hindi. So, para malaman kung cyclic, titingnan lang natin yung element ng C9. So, we have 0, 1, 2, 3, 4, 5, 6, 7, and 8. So, mapapansin natin dito sa element ng 1, 2, 4, 5, 7, and 8 na same lang siya kung ano yung nasa element ng C9. So, it means cyclic siya. So, the elements generated by 1, 2, 3, 4, 5, 6, 7, and 8 is exactly the same as the group. So, therefore, C9 is a cyclic.